Guys, so what we talked yesterday. Yesterday we started the discussion by saying that there are three types of what I call primitive preferences. These are risk preferences that govern our decisions or the trade-offs that we do between risk and return. There are time preferences that govern our decision between today and tomorrow. And there are social preferences that govern our decision between ourselves and other people, our consumption, our well-being, and the well-being of others. And I made the claim that of course, I cannot really provide any, any proof to, that all decisions in life, large and small, are somehow governed by these preferences. And you didn't object. And what we did yesterday, we focused on these preferences. And the reason why we focused on these preferences, because it's a summer school on social economics, so we focused on social preferences. Although the questions that I outlined, which I call the four fundamental questions about preferences, can be asked about any type of preference ordering here. What I want to do today, I want to basically first develop the preference ordering that I would call moral preferences. Okay? And of course, this preference ordering, I will need to describe the objects of choice on which your trade-offs are governed by what we call moral preferences. And because I said that these are the primitive preferences, there will be a question whether by these preferences I can basically pin down uniquely what are your moral preferences. Okay? So this is what we are after. However, before, just to give you a glimpse about the question that we can ask with the techniques and everything that we discussed yesterday on other preferences, let me speak for, just take 5 minutes in order to speak about time preferences. Okay? It's not in your notes. This is I decided based on the discussion that I had yesterday with some people. Okay? Okay. So when it comes to time preferences, I want you to think about decisions over budget sets again. That now, let's say that the money that you allocate to account Y is going to be paid sometime in the future, and the money that you allocate to account X is going to be paid nearer in the future. So you can think for yourself that X is money today and Y is money tomorrow. So if you pick this allocation, for example, then you will get this amount of money in the future and this amount of money today. And of course, in this experimental design, it only makes sense to have positive interest rates, so the intercept with the Y account should be higher than the intercept with the X account. Okay? Now, much of this, why am I talking about time preferences and not risk preferences? Because risk preferences, we will need several hours to talk about, you know, starting from Van Neumann-Morgenstern, moving to Savage, and moving. There are basically, I counted between expected utility, of course, and more than 30 non-expected utility models. I mean axiomatic foundations that basically relax the independence axiom. So if we are going to actually get into risk preferences, it will take forever. Okay? Let me just say that all of the models that modeling risk preferences assume from the beginning complete and transitive preferences that also satisfy the first-order stochastic dominance. Okay? And the entire discussion in the domain of risk preferences is about the independence axiom. So if we'll think about it in terms of the 4 questions that we outlined yesterday, no one is checking for consistency. We take it for granted. And then everybody started saying about a particular structure, but basically independence. When we come to time preferences, there was no work on axiomatic foundation. There is very little work on axiomatic foundations of time preferences. People are just writing utility function and tweaking them as they are so inclined. However, An important interest here in this literature was that time discount rate declines as trade-offs are pushed into the temporal distance. So in the standard survey, you would ask someone, what do you prefer, $10 today, or $100 today, or $110 in a week? And this, usually people will say, give me $100 today, although given the interest rates, you should wait a week. And then when you push this decision into the future, you ask them, what do you want, $100 in a year or $110 in a year and 1 week? Everyone moved to give me $110 in a year and 1 week. And this is, of course, mean that time preferences are not stationary. It's not only between the difference between these two time dates. So this is what is written here. Subjects in experiments or in surveys often chose the larger and later of two rewards when both are distant in time, but refer the smaller and earlier one as both rewards draw nearer to the present. People interpret this as non-constant time discounting and what we call preference reversals or time inconsistency. And of course, the model that we are working with is the kind of beta-delta model. So under standard assumptions, and when I mean standard, I don't mean that they are non-controversial, they are just standard. Non-constant time discounting implies time inconsistency. And then we have all of these self-control problems and demand for commitment. And this is, of course, why this is a big interest. Okay? Can I write with this on this?
You can do it at least once. But
no, I shouldn't, right? Yeah, I'm a little bit afraid of this lady that gave the introduction. And if I destroy this board, I'm sure that she'll come after me. Maybe, okay, I'll tell you what I'll do. Let me.
While you're
Yes.
technology, can I ask?
Of course, I cannot do, you can ask the question, but I cannot do two things at once. Oh, okay. Okay, I cannot read even. Yes, ask me the question.
Right, so you know that there's a formal relationship between time and risk preferences, right? So and they're essentially the same thing, right? So in the von Neumann-Morgenstern world, right? So if you want to have additive and separable preferences over time, you're going to have an independence axiom, et cetera, et cetera. If you want to have what you've got down here, right? You can also do this with Choquet discounting.
That's right. So Larry wasn't in our discussion yesterday. He preferred to go and buy a hat.
I have it.
You see, very nice hat. So you did your trade-offs, and I will not comment on this, except for saying that it's not completely right and it's not completely wrong. So we can start a discussion about it. But it's related to things that I said yesterday, so we'll discuss it. Okay, that's fine. So now let me tell you what I want to do, and I think that the result will be, and we'll discuss the result. So remember again the questions that I have in mind. The first question is consistency. The second question is structure. The third question is recovering preferences. And the fourth is the heterogeneity and external validation of what we find. So the entire the question is whether people are beta-delta or not beta-delta, meaning whether the beta is less than 1 and they have non-stationary time discount rates. It's a question about the structure of the underlying utility function. Okay? It's a question about the structure of the underlying utility function. So again, we ignore the first question of consistency. So I want to do the following experiment. There are going to be choice problems, meaning budget sets, that will basically involve trade-offs between income in a few days and incomes, let's say, in 60 days after that. And there are going to be choice problems that involve trade-off between income in 60 days in incomes in 60 days after that. And there will be 50 decisions of each type. And people will do it in a counterbalance design. Okay? So basically, you're going to face this type of budget lines again. Y, X. X will pay at some time t. Y at time t plus 60. And in the two design, we are going to change what t is. Okay? And we are going to have data set that we call data set E. and we are going to have data set that is called data set A, data set L. So do you agree with me that about the following? What can we have? We can have people that have consistent choices on data set E, which means that they actually have a preference ordering, let's call it E. There are people, there are people that can also have a consistent choices on data set L. So they have preference ordering over L. Now, what happens if I combine the two data sets together? So instead of having 50 choices, I now have 100 choices. We can think about the case, someone that is consistent here, and also consistent here. You agree with me that your GARP score, your consistency score in the combined data set can be no higher than your consistency score in your separate data sets, right? Because they contain all mistakes. Okay, and now there can be someone that is consistent here, but is inconsistent here. He doesn't have preference ordering here. These are the people that are basically beta delta. These are the people that are time inconsistent. This is a person that is consistent and time consistent. This is the person that is consistent but time inconsistent, meaning there is a preference ordering that will explain his choices in the early time frame. There is a preference ordering that will explain his choices in the late time frame, but these preference orderings are different. So he is time inconsistent. Now, of course, there can be other types that they are basically just inconsistent. And if you are inconsistent, of course, you will be time inconsistent, okay? So now the question, how many people are falling, especially what's important to us, it's here, okay? I don't want to get exactly how we do this test, but these are the people that have non-stationary time discounts. These are the beta delta people, for example. Out of thousands of people, almost none. 0. Okay, 0. Exactly 0. So everything that we are talking about, time inconsistent, we attribute something to structure that absolutely doesn't exist. Doesn't exist. Just 1 minute, let me show how it's done. So what you see here is the CCI score, and it seems that there are not many people here, but there are 1,500 people here from a representative sample of the population. You just don't see them because many of them are very consistent. Okay? So this is the CCI for the combined data set together. There are many ways to do this test. It will give you exactly the same picture. And here what you can see is the mean CCI between early and late. Why? Because the combined CCI can be no higher than the mean CCI. My friend, you've been in a place far, far away yesterday. CCI is a measure of CCI is a measure going between 0 to 1. If you are 1, you are perfectly consistent with utility maximization. If you are falling below 1, the difference between your measure and 1 is the amount of money that you are wasting, quote unquote, by being irrational. Okay? So you want me to introduce to you a person that is beta delta? Here she is. This is a true beta delta. Consistent in the early time frame, consistent in the later time frame, but have very different preference ordering. And there are 1,500 people here. Okay? Yes?
So I would like your opinion on, because the discussion is a little bit saying that if in monetary terms you're not going to find this beta delta preferences anyway because you're
I love it.
So
this,
you shouldn't find
yeah.
any of that, and
No.
then in consumption
Yeah.
you find this, but you work on money, so then it's clear that you shouldn't find
Okay,
it.
so my answer to this, I'm coming from the mecca of behavioral economics. I heard it. And then I also heard that the beta delta is about now. And even if I give you not money, I give you goods, but you don't eat them immediately, then the beta delta is not important. So my answer to these people, if you want to write models that are not about money, and you want to write models that are about now in terms of milliseconds, go ahead and do it. My condolences. Yeah, go ahead and do it. Go ahead and do it. What can I say? You are right. This is about money.
And also the experimental results you were citing earlier, it's just about benefits.
No, the issue here is whether it is the external validation of these results relative to other results. Look, if I go and I ignore this, I'll forget about this, and I'll start just putting a utility function and estimate parameters. My estimation is going to be way, way better than any other structural estimation done in this literature. Why? Because I have 100 decisions here over a range of budget sets in an experiment that provides a very strong test of revealed preference conditions. And as we know, revealed preference conditions contains all information about preferences. So there is a one-to-one relationship between the affiliate inequalities and the Slutsky metrics. And we are in the business of recovering the Slutsky metrics. So if I come with an experiment that is powerful in detecting revealed preference violation, I have enough data to recover the preferences. If I forget about it, I just forget, and I do what everyone does, and I just estimate this, all of these people, what will happen? They are inconsistent. There is a lot of noise in their data. So the beta will start moving in order to basically account this noise. So if I forget about everything I tell you now, and I just estimate, you will get that many people have beta significantly less than 1. But this is just in your own mind. This is in the model that you estimated. Basically, you cannot estimate for them utility function because they don't have a utility function that can explain the entire data set, period. Okay? So if you want to tell me if instead of money, I gave these people apples and oranges, or apples today and oranges tomorrow, and it will work, so I will write it. Go ahead, write models on apples and oranges. It's fine. I have nothing to say. Absolutely. So this will be published in the American Economic Review of Apples and Oranges. Or should be. Okay? Can I go back? So this is absolutely wrong. It doesn't exist. It comes from our own mind. We wrote a nice model that can explain to us something, then we fell in love in this model, and now any empirical evidence that is going against the model is completely forbidden, and we are just moving more and more to think that.
In that model, what's the percentage of people that are simply inconsistent with anything?
So you can. I don't want to get into this. This is not what we are talking about. The point here is to say that without theory, without revealed preference theory, there is no way to proceed. There's just no way to proceed. It's like what we learn in first year of graduate school. We throw out of the window and we start scratch. Maybe we should cancel first year micro. There's no point teaching it even. So you can say, we can talk about the fraction of people that are consistent and whether this person is sufficiently consistent that we can think that he is maximizing utility function subject to a trembling hand. There are many questions here. But specifically, there are no people that are falling here. There is just no people like this. There are thousands of people here. Representative sample, on real stakes, doing their experiment at home. Okay. Okay. Moral preferences. So, as I said, we didn't coordinate in this summer school, right? We didn't coordinate the topics of the talks. I didn't know that Armin is going to be here at all when I sent it, but now I think it comes together very nicely. No, I think I moved first. Yeah. No. I made the point yesterday that actually, we didn't coordinate. There are summer schools that are very coordinated. There is kind of it's a preaching exercise for something, and we didn't. So it's nice that it actually combines together very nicely. Remember where we are going. I won't actually, I didn't even define to you what moral preferences are. I will define what moral preferences are, and we will be able to discuss what is moral. Okay? And there is a big question. You know, in the type of experiments that, for example, Armin talked yesterday, and the provoking example of pushing a fat person, or let's push a fat lady on the train tracks, and I'm sure that if you say a fat person or a fat lady, at least in America, it will make a big difference whether you push her or not, because, you know, until the fat lady sings, the game cannot be over, so it's a problem. But in some sense, it's a binary decision. It's a binary decision. And there is something that we would consider moral and something that we will consider immoral. And part of the claim that I will make is that there might be even people that agree what should be the standard of moralities to a certain extent, then they will diverge of what is the moral thing to do. Okay? So I'm not going to go back to Kant. Okay? This is, with all due respect, we'll start from Harsanyi and Rawls. So Harsanyi and Rawls argue for theories of social justice, or equivalently, they called it fairness, based on the choices that people should make for society and themselves in what they call the original position, or behind the veil of ignorance. Let me say up front that Harsanyi and Rawls came to very different conclusions, which will be important for us, but not necessarily because they view the original position differently. You know, in Rawls, the original position is that I need to erase your brain, and you need to make a decision before your self-awareness returns. In Harsanyi, you are very aware. You are actually an expected utility maximizer. You basically know statistics. And after Rawls published his book, there is a series of papers that Harsanyi responded to this book. Unfortunately, Rawls did not really respond back, which I think made Harsanyi more and more angry. So the papers are becoming funnier and funnier. But in one discussion that they actually had, Harsanyi told Rawls, you know, in part of Harsanyi's model, there is expected utility. And Rawls told Harsanyi, expected utility is a theory of gambling, not of moral choices. And Harsanyi replied, no, expected utility is a theory of rationality. And if you want to make good moral value judgments, you have to be rational. Okay? So I will talk about the original position, but I will basically talk about it a la Harsanyi and not a la Rawls. So what is a la Harsanyi? The original position, you are making a decision in the original position. If you don't know your own social and economic position, your own special interest in the society, or even their own personal talents and abilities or the lack of them. This is a definition from Harsanyi in 1975. So let's focus on Harsanyi, and let's think about the following situation. Suppose an agent wants, I didn't say that you have to, but suppose you want to make a moral value judgment about the relative merits of two alternative social systems. For example, this happens to me every 2 years, or even more often. I need to go to vote, and I can vote on something like, let's increase property taxes and spend the money on public schools. You know, I'm coming from California. So how Sachar, I don't even try to be moral in any way. How Sachar votes on this? Immediately, you know, some back of the envelope calculation. How much it will increase my property taxes given the value of my house. I try to remember how many kids I have. I calculate, you know, how many years they have in school. This is what I pay because of it, and this is what I will gain because of it, and then I make a perfectly selfish decision. Part of the reason that I'm doing it is because the recipe, in some sense, that is given to me by Harsanyi, how to do this, how to make good moral value judgment, is actually very hard. So Harsanyi tells me, I need to act in a way as if I assign the same probability to me occupying each social position under any system. So I need to go to all people in my town. It's a small town, but still, you know, there are thousands of people there. And I need to think about myself exactly, so to put equal probability that I'm each person in my town. I need to think about their preferences also, and I need to maximize a weighted average of all of these preferences. The issue about doing so, then Harsanyi is basically claiming, that if someone is doing so, he would clearly satisfy the impartiality and impersonality requirements of the original position to the fullest possible degree. There is no point erasing someone's brain. So basically, an agent has different sets of preferences. These are personal preferences and moral preferences. Personal preferences are basically social preferences, risk preferences, and time preferences. And there is these moral preferences that are something different. So let me make two observations. Both Harsanyi and Rawls insist that moral preferences must conform to certain rationality requirements. So in Rawls, you must maximize the Leontief function. In Harsanyi, you maximize perfect substitutes. So basically, they are saying that as opposed to personal preferences, which are tastes, and they, of course, allow heterogeneity. Harsanyi doesn't tell you you have to be more risk-averse than other person. He accepts that we will have different risk aversions, but he doesn't accept that we are going to have different moral preferences. So this is, I think, the first point that we need to talk about moral preferences. You can have different preferences over apples and oranges, but you need to do the utilitarian thing. Yes?
Does Harsanyi require consistency in that your personal preferences are the conditional moral preferences given what your type actually turned out to be?
So this is what this is exactly where we are heading. He is bypassing this, basically. He said, you have preferences. Yes?
So when you put yourself in the other person's position, are you using their own?
No, you need to know his preferences, at least. Yeah. Now, both Harsanyi and Rawls and many other writers, they view the original position as a purely hypothetical environment. Rawls said it's like grammar to linguistic. And hence, they view moral preferences as a purely intellectual construct, right? So if you can think about it, why do we write models, or at least why I think that I write models? First, I write models because I think this is the normative thing to do. So this is how people should behave. And I think that many models in economics, there is a place to write normative theories. Then, of course, we write model also, we hope that they will be a descriptive theory. They will actually say how people actually behave. And we also write models that are prescriptive theories. Basically, they give you a prescription what to do. So the theory of second price auction, it basically tells the auctioneer exactly what to do, gives him a prescription. These models are normative models, which doesn't mean that they are not important. So I think by the use of theory, and the use of theory is basically thinking about these linkages between these moral preferences and the three basic preferences that I introduced, I think we can achieve two things. First, I'm going to show you that under certain conditions, and I'm not going to say whether these conditions are large or small, or important or not, restrictive or not, I would claim the choice behavior behind the veil of ignorance can be decomposed into choice behavior in front of the veil of ignorance. The type of moral preferences that I will put under certain assumptions will be completely determined by your risk preferences and social preferences. Okay? So at this point, there's basically, it's about nothing. There is no point even talking about moral preferences. They are predetermined by the basic preferences. And then I will show you the choices behind the veil of ignorance to a certain extent can be presented in the laboratory with real stakes in a controlled laboratory setting, as well as preferences in the other environments, like risk preferences and social preferences. So these theoretical linkages that I'm going to put can be tested. Questions? Okay, so now we'll need to think about how to think about these results, and the arrows means either positive or negative. If you like moral preferences, what is called moral preferences, you think it's important, and you think that we need to continue the discussion about moral preferences. Then the linkage between preferences behind and in front the veil of ignorance provide new ways of interpreting these moral preferences, not just as a normative theory, but also as a descriptive theory and even as a prescriptive theory. I will take the other view. The other view is the linkage means that moral preferences cannot occupy such a privileged position in our discussions. Okay? So given certain assumptions, they are completely determined by risk preferences and social preferences, and the entire discussions about morality is complete waste of time. Okay. I will take the second view. If you want to take the first view, that's fine too. Whatever you want, whatever makes you happy. Just be consistent. Okay, so here is the template for our analysis. I'm going to present the simplest version of this where there are only two people. All the results that I'm going to say are going to extend to any number of people. So I want you to consider choice behavior by a single agent in free environment. Each choice will have consequences for self, that's the agent, and an unknown other. Okay? So when I say unknown other, I will make here a simplifying assumption that I will basically, because it's an unknown other, and I think that there is a serious problem of thinking about the preferences of the unknown other, I will talk about consumption. Okay, but there is a way out. Okay, there is a way out. It just makes things very complicated because then you need beliefs over. Okay, I'm going to consider environment that will involve binary choices, only binary choices, and equally probable lotteries. But the result extends basically to general choices and lotteries and to unknown probabilities as well. I can also introduce ambiguity. Okay? So I want you to think about lotteries over outcomes A, B, where A is going to be the consumption for self and B the consumption of other. And for our purposes, again, I will only consider binary lottery. So the choice space of individuals in my world are lotteries of the same form. 50% chance that I will get A and someone else will get B, and 50% chance that I will get C and someone else will get D. Okay? Now, we will think for simplicity that A, B, C, and D are all positive. So 0 is basically survival level. We are not killing anyone here. We are not pushing anyone over the tracks. And we are going to write L for the space of all such lotteries. And we are going to identify L with convex cone and R4 plus. Okay? So first I'm going to claim, let's suppose for now, that there is a preference ordering over objects like this. What are these objects? These objects are lotteries over social consumption. So if you ask me what it is to be president, what do we mean by someone who is a president? When we elect a president, we are electing someone to make choices over this space L. Okay? That's the point. This is basically what we do. You know, in entire social choice theory, basically, it's a deterministic world. You know, if you open Mascolel, open social choice, it's a deterministic world. But basically, being a president is not choosing deterministic actions that have deterministic outcomes. You are basically choosing acts that have stochastic outcomes. You are choosing over lotteries. Whether I should send these soldiers to, whether I should attack Iraq now, how should I attack, whether, you name it. You name it. Now, let me just tell you that immediately, I'm not in moral preferences yet, okay? I don't know how to call these preferences, this large preference ordering over the set L yet, because it somehow combines risk preferences and social preferences, right? Somehow, in a way that I will explain in a minute. But do you agree with me that this is the preferences, this is preferences of a policymaker over objects of choice? Now, usually, when candidates are running for presidency, we are very interested in whether, for example, they smoke, they cheat on their wife, or they invest aggressively. Why? All of these behaviors that I just mentioned are basically behaviors that are over risk preferences over your personal consumption. But we sometimes feel that from learning this, I can basically know something about this, right? Or otherwise, I don't know, we just want to read the interesting newspapers with interesting pictures. So the best example about it, probably there are a few people in the audience that know and remember, is Gary Hart. So Gary Hart was the front runner for the in the Democratic presidential race. And then he was caught on a boat with a lady much younger than him and obviously not his wife. So, and this destroyed him. It completely destroyed him, and he had he went out of the race. And basically, you know, cheating on your wife, I think you can think there is something about it in terms of social preferences, and there is something about it in terms of risk preferences. It's a very risky behavior, but it's done in the personal domain, right? It's done in your personal domain. And for some reason, I can only understand the fact that people said, we don't want to hear about Gary Hart. It's that because they thought there are some linkages between this and that. Okay? Okay. Now let's try to make it precisely, because without actually writing axiom on theory, there is no, on preferences, there is no way to proceed and to make it precise. Yeah. What is moral basis? Okay. So I will write a theory that we can basically have a horse race between these two arguments. Okay. This is something that I don't want to discuss is French politics. It's beyond my understanding. Actually, the incompetence is beyond my understanding. If the French president cannot have an affair quietly, then how can, you know, how is he competent enough to actually run the government? Yes, exactly. Incompetency. you know, the Secret Service cannot tell you how to go to your mistress without reporters catching it. Okay. It just shows the incompetency of the French government. Okay, so now I want to take this environment and I want to start looking at slices of this environment, okay? So I want to define closed convex subcones of L. How am I going to define these closed convex subcones of L? First, in choice space R, Larry, you have to be well behaved. In choice space R, I'm going to take C and D and equate it to 0. 0 is not really important here. It will be nice, but let's suppose that I'm taking C and D and equate it to 0. So when I'm making choices over choice space R, I'm making choices over lotteries that have no consequences on the other person. Okay? Now, let's take choice space S. In choice space S, I'm going to basically equate C to A and D to B. So these are degenerate lotteries. And on these degenerate lotteries, I do make choices that have consequences for myself and for the other person, but there is no uncertainty. Okay. So you agree with me that on R and S, we already discussed the preference ordering that are relevant are risk preferences over own consumptions and social preferences over deterministic social outcomes. We discussed these two preferences. Finally, here I'm going to define moral preferences. And moral preferences are preferences where I'm forcing you to be behind the veil of ignorance. Okay? I'm forcing you to make moral choices. So moral preferences is like I need to cut the cake while not knowing which part of the cake I'm going to get. Okay? So moral preferences are the space that I'll call moral preferences, or the subcones are choices over lotteries that with 50% chance giving me A and the other person B, and with 50% chance vice versa. So I define moral preferences as preferences, the preferences over subcone M. Questions? Okay. So we can basically identify each of these environment, as I said, with risk, social, and moral choices. And the formulation of moral choices is basically not exactly, because it's not over preferences, but we can do it over preferences. It's basically Harsanyi's formulation of the original position. Okay, so now, what? What? This is again. Social preferences actually means that there is nothing to understand preferences. You need to understand the choice sets. So the choice set in social preferences is a subcone of the choices in space L, where in all of them it's only choices that with 50% chance I get A and 50% chance AB and 50% chance AB. According to the sure thing principle, right? This is just degenerate lotteries. I'm going to get A, you are going to get B. So choice space S is A can be any number and B can be any number. So basically, choice space S is this. Pi S, pi O, consumption for self and consumption for other, and this is choice space S. What is choice space L? Choice space L are basically lotteries over this space. Okay? What is choice space R? Choice space R are only lotteries here. Do you see this? Okay, choice space S, lotteries over only here, choice space R, lotteries over everything, choice space L. Okay, yes?
So here Harsanyi rolls aligned, right? So you put all your
Harsanyi rolls are never aligned. Now they are aligned, they are both dead. But except for this, they are not aligned. It's basically that, you know, in some sense, when I will give you decisions over choice space M, I'm forcing you to be behind the veil of ignorance, but still, you know, I might know my own preferences, and I know your preferences, so I'm not putting myself in the veil of ignorance in that respect. But in terms of consumption, I'm putting us behind the veil of ignorance. Of course, philosophers will argue bitterly that I even say the original position here. Okay, so now we have some research question here. Let's leave the research question. Let's get. So the first thing that I'm going to do, I'm going to make few definitions. Here are the definitions. Any questions? Here are the definitions. I'm going to write preference ordering for L, and I'm going to write preference ordering R, preference ordering S, preference ordering M for the restrictions of preference, the large preference ordering on each of the choices. Okay? And to begin with, I'm going to I'm going to state now several assumptions about these preferences. I will try to make assumptions that later on, of course, I can test. Some of them I couldn't test yet. Okay? What is important about these assumptions? These assumptions are necessary and sufficient conditions such that if I know your preferences over your preference relation R, meaning I know your risk preferences over your own consumption, and if I know your social preferences, then knowing this preference ordering and that preference ordering will pin down precisely, exactly, what is this preference ordering. So if we think about it about a president, if we knew Romney's risk preferences and we knew his social preferences, then we can pin down exactly what he will do when he's in office. I will give necessary and sufficient conditions for this. However, if these two preference orderings that we observe in practice and we have a lot of information on, both experimental and non-experimental, this is my view why Romney didn't want to show us his tax returns. Okay? Provide a lot of information here. Okay? But if the assumptions are correct, then the fact that these two preference ordering pin down this preference ordering, it also pins down this preference ordering. So this is what I mean, that the moral preferences are completely determined by risk and social preferences, and I think that we can forget about this. Okay? So again, to the picture, remember what we said. I know the preference ordering here. This is preference ordering S. I know the preferences here over lotteries over here, and this preference ordering R. And this basically, the conditions will allow me to understand the preferences over lotteries over this entire space. Okay? Okay, so let's start. So the first assumption that I'm going to make 4 assumptions, and you can object, but these are assumptions. Some of them I can test, some of them I cannot. So the first assumption that I'm going to make the assumptions that the large preference ordering satisfies the usual requirements. It's complete and transitive, reflexive, and continuous, and obey the sure thing principle. Meaning you can understand that the lottery, I'll get A with probability P, and B and A with probability 1 minus P. It's just I'm going to get A. Unfortunately, this preference ordering, even in the simplest example, is in R4. Okay? And I don't know how to take the experimental technique and to present people decisions in R4. I can do it in R3, but I cannot do it in R4. Okay? So it will be very hard for me to test. Okay? However, the rest, in some sense, it can be tested. So the first assumption, anywhere here, there will come some independence, some type of independence axiom. The independence axioms that we have here, we call it weak independence, but it's much more than weak. It's very weak, in the sense that not only that it doesn't imply expected utility, all models that I know, all models of decisions under risk satisfy this axiom. Okay? So I think it's hard to argue against it. If you want to argue against it, you need to come to me with a model with a weaker assumption and start doing preferences under risk. What does this assumption says? This assumption says, suppose that Larry tells me that for him, social outcome AB is better than social outcome A prime B prime. This is he's doing using his preference ordering S, because these are deterministic outcomes. And he also tells me that for him, social outcome CD is better than social outcome C prime D prime. Again, these are deterministic outcomes. He's doing it with his preference ordering S. Then he must tell me that the convex combination of A, B, and CD is better than the convex combination of A prime, B prime, C prime, D prime. Why it is not the independence axiom? The independence axiom, the standard independence, is from lotteries to lotteries. And here it's from deterministic outcomes to lotteries. Capish? Okay. Okay. Now the philosophers are starting to become uneasy, and for no good reason, in my opinion. So let's have 2 other outcomes, 2 other assumptions that I will need them. Now, the reason why I need this assumption is purely technical. It's purely technical. It's almost like continuity. I need it together with continuity to get what I want. But this assumption, you can make them look bombastic. So the first one is that 0, 0 is the worst outcome. So I would prefer any AB to 0, 0, meaning including I'm getting 0 and you are getting something positive. So 0, 0 is the end of the world. Okay? We are both in our survival level. On the other hand, I'm also assuming people are self-regarding. What does it mean? You take any social outcome that I'm getting A and Larry is getting B. You can bribe me. You can give me enough money such that there is enough money S, such that I will prefer Sachar having S and Larry is a homeless to AB, for any AB. So this assumption 3 and 4 are basically limiting how individual can be altruistic towards others and how they can be spiteful towards others. And if you think about it, what these assumptions are limiting, these assumptions are limiting that preferences will not be non-well behaved. So for example, according to Fair-Schmidt, we talked about it yesterday, which are not well-behaved preferences. They are non-monotonic, basically. Of course, someone who is a Fair-Schmidt would prefer to kill us all. Okay, because he doesn't want somebody to live. You know, he has this utility from somebody that is in front of him. Yes?
So this assumption says a couple of things. Does it, is it necessary that, that the worst outcome in the social preferences be zero?
No.
Or
No.
just that there is?
Yes.
No, all right, that's fine. And then, I know that, does this imply that there is a worse moral outcome?
Okay. So, so first, in some sense, outcomes cannot be.
I mean, a worse moral
yeah.
lottery, you know.
Yes. 0-0.
Yeah, okay.
0-0 is the worst outcome. It's survival of all of us.
So even when we move to the lottery?
Yes.
Okay.
Yeah. Yeah. Okay. Questions? Okay. Now, this is the simplest framework. I can send the papers that people are interested. There are a couple of papers that we wrote like this on different. We just wrote the theory in different ways, and the experimental results that I will present are not available yet, but I can send some drafts of them. Okay, so what is the result? Every preference relation, let me just say that, you know, look, most of the assumptions here are basically done on preference ordering S, right? Which is basically the preference ordering that we observe. You see, preference ordering, assumption 3 and 4 are done on preference ordering S. Okay, so what is the result? Every preference relation on L that satisfies assumptions 1 and 4 is completely determined by its relation, by preference relation R and preference relation S. Okay, this is a sketch of the proof. It's necessary in sufficient conditions. Okay, so what that means, it means there is a unique mapping. Now, you can ask me a simpler question, basically, is there a mapping at all, even multiple mappings? But here I'm giving you, and this is a simpler question, but here I'm giving you the necessary and sufficient conditions for a unique mapping. Okay? Now, of course, whether, for example, the voter that observes preference relation R and preference relation S can actually do this mapping, this is a completely different question that I have nothing to say about. Okay? But of course, if there are more than one mapping, it might only be harder. Okay? But I have nothing to say about what is the complexity of this mapping, whether there is any chance in the world that we can actually do these mappings. Okay. So here is a sketch of the proof, which is basically, in this case, I made it as simplest as possible, but not simpler, as our founding greatest fathers of all science told us. So let's fix an outcome XY. Now, because the preference ordering over S is self-regarding, there is some S such that, right, S0 is better than XY. Now, I'm basically going to use continuity to get selfish equivalences. I need to get exactly the right one. So this is the hardest and most tedious part of the proof, because you want to know that there is a single crossing here. But all of the assumptions that we made are exactly for single crossing. If there is no single crossing, then there might be more than one mapping, of course. So I'm going to define selfish equivalence of XY by calling it sigma XY. This is basically the inf on S such that S0 is better than, weakly better than XY. And continuity and the assumption of worst outcome guarantee that sigma XY, I'm getting sigma XY, which is basically the inf S here, that when I'm getting sigma XY and the other person is going to get 0, I'm indifferent between XY. So this is exactly the selfish equivalent. Okay, then what do we have? By construction, person self is going to be indifferent between AB and the selfish equivalent of AB, and will be indifferent between CD and the selfish equivalent of CD. Then weak independence basically imply that I should be indifferent between 50% chance AB and 50% chance CD, and exactly the same convex combinations of the selfish equivalences. So basically now we can say that you give me any element in L, basically this lottery, 50% chance AB, 50% chance CD, and another lottery, 50% chance A prime, B prime, 50% prime, C prime, D prime. I will prefer this lottery only if I prefer the selfish equivalences. And the selfish equivalences are over R. So this is what we did. We decomposed preferences over L into preferences over S by using selfish equivalences as preferences over R as desired, end of story. Okay? Questions? Okay, now let me just, okay, let's continue. So now, given a linear budget constraint, let's suppose that we have a linear budget constraint. And how do I want to think about this linear budget constraint? Exactly like we thought yesterday. So given a linear budget constraint, we are going to identify choice behavior in the social choice environment if selfish. So look, this is not preferences, this is choice behavior. I will say that your choice behavior is selfish if the choice subject to every budget constraint is of the form of Y0, okay? Like we did yesterday. Y0 is taking everything to yourself. And I'm going to call the choice symmetric if you're going to make the following choices. If you choose, if AB is chosen subject to the budget constraint PX plus QY less or equal than W, if and only if BA is chosen subject to the mirror image budget constraint. And if you can see, this basically means that you are fair-minded, right? That your indifference curves are symmetric across the 45-degree line. Oh, so this is selfishness. It's one end of the extreme. This is fair-mindedness. Okay? Okay. So now let me give few simple results that will be, they're just, here basically the linkages between preferences are very easy to see. Suppose, now by the way, now I don't need 3 and 4. Just suppose that the large preference ordering satisfy 1 and 2. And let's suppose that choice behavior in choice space S is selfish. Do you agree with me that then choice behavior in R must be exactly the same like choice behavior in M? Otherwise, there is some inconsistency. Because if I'm perfectly selfish, if you give me a budget line, and this budget line is going to be in choice space R, or whether it's in choice space M, it really doesn't matter to me. Okay? And there is a small proof here, but of course it's trivial. What is the second result? Again, if the large preference relation satisfies 1 and 2, and choice behavior now is symmetric in the sense that we explain, then choice behavior in S is basically going to be exactly the same like choice behavior in M, regardless of your risk preferences. Okay? So the way to explain it is as follows. We are going to have now 3 experimental treatments. In the 3 experimental treatments, you will always see budget sets. The 3 experimental treatments will differ by the interpretation of Y and X. In choice space R, it's going to be lotteries such that if you choose a point like this, let's say XY, in choice space R, you're basically choosing a portfolio of arrow securities, and then there is 50% chance that you will get either what you allocated to X or what you allocated to Y, and what you allocated to the security that is not realized is basically lost. This is the risk preferences. In the social choice environment, it's exactly the same budget line, but now the interpretation of the goods are different. You know that you will get Y, and someone else will get X. And in the moral choice, and this is why I can test the moral choice, because I can represent it in 2 dimensions. In the moral choice, every choice from the budget line, there is 50% chance that you will get Y, and someone else will get X, and 50% chance vice versa. So I cannot test the linkages to L, and I need to make assumptions that L satisfies 1 and 2. So I'm starting on very shaky grounds here. Okay, that it will be very disturbing later to me. But I don't know how to, I don't know how to present choices on L in a meaningful way. Meaning a way that subject can understand and they will have a strong test. Okay, so let's skip the proof. And let's do we did these experiments over the years at Berkeley, UCLA, Norway, whatever. So in this experiment, again, choices are from these two-dimensional graphs, and people are going through 150 decisions, 50 in each domain, and we are doing it in a counterbalance design, meaning some people are starting with R, other people starting with S. We are mixing this. We have thousands of people that did it, a variety of people. There are no order effects. Do I need to say anything else about it? It's clear, right? Okay, so let me start by actually something that is not on your notes. I added it at the end. I want to introduce to you some subjects, show you really what I mean by these fingerprints of economic behavior. And what you see here, I'm going to show you a series of graphs. So meet this person. This is ID 11. And in the experiment that I'm going to show you, we change our minds what gives us a stronger test. Sometimes we did that the 50 choices that you receive in each of the domains are the same lines, but they are randomly ordered. So we thought that this will give us a stronger test because you can do pairwise comparisons. Then I actually understood that this is wrong. I should have known it to begin with, and actually there should be random choices at each 50, okay, drawn at random. So basically, the line that you observe in each choice in this data will not be the same, okay? Will not be the same. So what you see here, on the x-axis, you can see the log of the price ratio. So this is basically a budget line with the slope of -1. And here you see y divided by x plus y. So this is the fraction of tokens that you allocated, the relative demand to account y. The black dots, there will always be 50 dots here. The black dots are basically decisions in the social choice environment, in the dictator game. The blue dots are in the risk, and the red dots are in the moral. And I think that when we will look at these scatter plots, you will see everything that is good and bad about what we do. Like everything, it will just stare at you, everything good and bad. In order to make things simple, I'm going to start with people that are perfectly selfish. You see, this person is perfectly selfish. In fact, he's a selfish bastard. So you can actually see the range of prices that were in this experiment. So this person probably here faced something like keep $5, you can keep at most $5 and give $100 to another person. Okay, this is what we are talking about. But you see, it's a human being. Something happened here. It's a human being. Okay, so what are the most basic result that I gave you? If you are selfish, then your behavior in the risk environment and your behavior in the moral environment should be exactly the same. Okay? Now, this is, of course, true under the assumptions that I made. Okay? Now, if it's not true, why isn't it true? It's not true because one of the assumptions that I made is wrong, period. Maybe you don't have complete and transitive preferences over L. Maybe you are not a worst outcome guy. Maybe many things, okay? Okay, so this person, I will talk later how to basically really test it empirically, but this person, you can just stare at him and you would say, okay, this is fine. You see, this person is very different. So what this person is very selfish and infinitely risk averse, right? So he's very selfish, he's infinitely risk averse, and he's behaving like a Rawlsian. Okay? This person is also very selfish. He's even more selfish because you see he observed more extreme prices than the other one. This guy is even more selfish. Or at least it revealed that he's more selfish. He's risk neutral. He's risk neutral, and he's utilitarian because his risk preferences pin down his moral preferences. This guy is maximizing very nicely and precisely the utility function log x plus log y. He's a Van Neumann-Morgenstern expected utility maximizer. selfish person, and his moral preferences are basically exactly like, you know, the egalitarian, exactly like Nash bargaining, basically tells us to do. Okay? I have a dream that in a core exam in micro, I will show these choices and I will ask what are the preferences and fail everyone. Just in order to tell future generations that they should be careful from this exam. Because if you fail everyone, then everyone actually passed, right? You cannot fail everyone. It will be very sad if all of us old people will stay alone in the department. But it will be a nice lesson to future generations. So this is a selfish person. Now, all of these people, let me say, within each choice set, they are consistent. There is a preference ordering R, there is a preference ordering S, there is a preference ordering M. What this person is doing, how his indifference curves look like. So let's look at the blue first. Let's look at the blue at his risk preferences. This preferences, of course, is not an expected utility maximizer. Expected utility is smooth. And here you see a very non-smooth behavior. In particular, according to expected utility, this person has split personality. Sometimes he's infinitely risk averse, and sometimes he is risk neutral. Right? So what this person is doing, if the budget lines are very steep, he's putting everything in Y. If they are very flat, he's putting everything in X. If they are intermediate, he's going to the 45-degree line. That's his behavior. You see it? As long as you keep the bounds where you jump from each, you will be consistent. Okay. So now can someone tell me how to draw the indifference curves here? Should I fail you? How the indifference curve look like? Open Gould 1991 econometrica paper, look at figure 1. Loss disappointment aversion, it will look like this. Okay? So you, excuse me? Farouk Gould 1991 econometrica paper, a theory of disappointment aversion. So talking about reference points, we are not in the business of trying to induce subject a reference point and later on see how well we induce them. We are in the business of seeing reference points. And this subject definitely has a reference point, and the reference point is the sure portfolio on the 45-degree line. And if you look at his preferences, this is his preferences. Moreover, wait, yes? Yeah. These are preferences. This is an indifference curve. And just to show you, I actually have this person in another presentation here that I can show you, if I can find him. There is no so. Let me just find him. Okay, look. This is an algorithm. This is an algorithm that only using revealed preference conditions put bounds on indifference curves. The algorithm was developed by Varian in this 1982 econometrica paper. And here you basically recover preferences non-parametrically. So these are how the indifference curves of a person like this, and I'm not estimating anything here. The indifference curves of a person like this can move in the white areas. The dark gray is the strictly worst set. The light gray is the strictly preferred set. This is where indifference curves are going. How the procedure is done. I have the 50 decisions of this person, as you saw it, and I'm asking myself, let's take a point and think about all the price ratios on which this allocation could have been chosen without adding revealed preference violations, without creating revealed preference violations with the previously observed data. And by the way that you are spanning these prices, you are basically getting bounds on the strictly worst set and on the strictly preferred set, and the indifference curves has to move in the middle, and you see that we are getting quite tight bounds. Exactly the same procedure can be used in order to non-parametrically put bounds on the inverse demand function on a budget line that was not observed in the data. Okay? So if you ask me whether reference points exist, yeah, apparently they are. Okay, but here you see them. Okay, so this is this person. Now, look, these are human beings. So you're going to see many types of behavior. I'm now showing you again, more and more people that we will agree with this. So remember, these are different budget lines. There are deviations, but you can see here very nicely that there is some relative demand function, right, to making sense with prices. Now, of course, when you look at a picture of someone like this, it will look more neat because he's doing something very simple. And this guy is actually trying to solve the trade-offs in some way, so there will be more noise here. It's more difficult to implement. Okay? What this guy is doing. This guy is risk neutral. Let's just talk about the risk. He's risk neutral. This is someone, I really want to meet him. This someone is beautiful because look, there is something that is just very hard to digest in what he's doing. So look here, he is here, this points actually show that, he's very selfish, very selfish. What is he doing? The choices of this, let's talk about the blue. He is risk neutral, but he has an interesting reference point. And the reference point is in $10. So what is he doing? He's doing the following. He's basically cutting the budget lines like this, and instead of going to the boundaries or to the excess, if it's steep, or he's going here. Why? Because he wants to ensure himself that he will get out of the experiment with $10. Okay? There's nothing wrong with this. But what is amazing here, that this type of behavior, I want this $10 aside, is basically transferred from the risk preferences to the moral preferences. Exactly the same. This is this behavior. This is why you don't see his choices here, because he wants to leave 10 in the other one. So he needs to adjust in this way, and the adjustment depends on the price ratio, of course. Okay. Okay, this person is not satisfying our relationship, right? He's perfectly selfish. When it comes to his own risk preferences, he's infinitely risk averse. When it comes to moral preferences, he's becoming a utilitarian. So here there is no question that we will reject the linkage. Why this happens? He's not satisfying one of our axioms. I don't know. It's very hard for me to know. And this person is probably his twin brother, who is doing exactly the opposite. Okay. Now, these are very clear. And for example, look at this. This is also very clear. His risk preferences are disappointment aversion, but his moral preferences are expected utility. Okay, so he is disappointment averse when it comes to only his own consumption, but when he have lotteries over social consumption, he is not disappointment averse anymore. Okay? Now, and you can see many things. So now, whether this person satisfies our linkages or doesn't satisfy, this will start to depend on how we test them. Okay? So now there is the question how exactly to test them. So let me just go over the last few ones. You see there are many different things. Okay? These are people that are symmetric. Everyone will look different. Okay? I think you get the point. Okay. Okay, so now how can we test this? So first, I want to make a point that the estimating preferences in a standard way that we are estimating them just makes absolutely no sense. Why? This was something I think you asked yesterday, because you can approximate always anything with a continuous function, but sometimes the approximation will not be very good. So let's suppose that you are estimating something. You can estimate kind of a Deaton, almost ideal demand system. You can do whatever. Think about that you estimated the demand function for the risk preferences. If you estimate it with a smooth function, it cannot capture this. It just cannot capture this. Okay, so any parametric estimation is very problematic here. Okay? So we will prefer something different. So now let me go back and start saying how we, if I can go back, probably I'm not going back now. Now, as you can see here, as I'm going, every person is different. We have thousands of pictures like this. There are no two people alike. Okay, so how are we going to test it? You know, for many subjects, as I show you, many selfish subjects seem to display the same choice behaviors in the risk and the moral environment. But there are many subjects that do not. Because of the nature of the data, any flexible functional form cannot provide a possible fit of the data for all subjects. Remember, everything is done here at the individual level. Okay? So, in particular, there is no satisfactory formulation to explain the switching between different types of behavior, which basically comes from this disappointment aversion. Parametric approaches may be possible. I don't know which one, but you know, some people like parametric. But you need to keep in mind that individual behavior are extremely heterogeneous. So you need to keep some very flexible functional form fitting flexible polynomials. I really don't know. But there are non-parametric approaches. The first approach, the non-parametric approach, I would say is an econometric non-parametric approach, meaning, and the other will be a pure statistical one. So the econometric approach will be what we did with time preferences, basically. Take the ratio of the CCI score for the combined data set to the minimum of the CCI score for the separate data set. And this measures the extent to which choice behavior in the two environments are basically the same. Unfortunately, even with 50 decisions in these data sets, the test is weak. We are not sufficiently happy with the test. Okay, the test is weak enough for us, and we need to think about what to do. So this is why it's still in our drawers. What will be the other approach? You can do a Kolmogorov-Smirnov type test. You can take a two-sample Kolmogorov-Smirnov type test on the equality of distributions of tokens and budget shares. The problem here is that these tests are very sensitive to the differences in both the location and the shape of the empirical CDFs. And we looked into what we call generalized univariate Kolmogorov statistic test. It might be the way out, but this is not something in Stata. And you know, now if we are not in our comfort zone in Stata, it's a problem. We don't know what to do. So this is out of our comfort zone. Okay. Let me take any questions, and then I will basically tell you that everything, this is exactly what I like to do at the end, that everything that I done is wrong. Yes?
So there are two additional things I wish you would do. One of them is I wish you would think about regret.
This is regret, no?
Well, I meant in the form of something like minimax regret, which that is not, because minimax regret won't satisfy, won't have utility representation.
Okay, that's true.
And I can give you an argument for later why I think that's an interesting way to think about the veil of ignorance.
Okay.
But I think that was a big thing. The other thing is that I you know, you talk about time risk and or social risk and moral preferences, but there's yet another dimension which I would call ethical preferences. Imagine that you had an experiment where you had yourself, other A, and other B.
Yes, we did it. We did it.
Okay.
This is we did. Okay, so this is we did. This is we did. Okay, so Larry saved me from telling you that everything that I done is wrong. Okay, I'll answer Larry, but I really think that everything that I done is wrong. Because I'm not solving the original identification problem that we talked about, whether it's preferences or constraints. I can get to it in a minute. So first, let me answer to your question. So I didn't have time to speak about it. I didn't even have time to show it to you. I can show it to you if I think we started 5 minutes. Now I'm negotiating. I think we started 5 minutes late. Yesterday I kept time. You didn't keep time this morning, so I deserve 5 more minutes.
Never negotiate in Israel.
Yes, exactly. Exactly. Either you agree or it's going to end badly. It's either you agree or yes, or we are both boiled in oil. Okay, so I want you to think about the following situation. Instead of giving you this two-dimensional budget set, I will give you budget set that this is, let's say, pi s. This is pi of some random person A, and this is pi of some random person B. And now I'm going to ask whether you have a preference ordering over this space. But in particular, I'm going to divide preferences into what we call social preferences. And these are basically the trade-offs between pi s and pi a, or pi s and pi b. And what I call ethical preferences, these are the preferences between A and B. And if we move to, this is why I told you that when we move to 3 people, we cannot think about it, we don't know, we couldn't pin the CES. But let's suppose that we have, you haven't been here yesterday, so I need to give you now a short special lecture. Apologize to them. So there are going to be here 2 parameters, alpha and rho. Rho is the curvature of this indifference curve, so it's equity efficiency trade-off. Alpha is basically fair-mindedness. It's whether these indifference curves are symmetric around the 45-degree line. So there is going to be alpha and rho, and here there is going to be alpha and rho. Alpha prime, rho prime, let's call it. Now, if alpha, because these are random 2 others, alpha prime should be 1/2, right? Otherwise, something is wrong here. And this is the case. But the question is whether the rho and the rho prime, how the rho and the rho prime together? Yeah. We answer this. Whoa! There's an answer here. Okay, we know this. This is known. Okay? Okay, so now why everything is wrong? It's not that everything is wrong. Everything is right under assumption that we never know. Okay, so we'll start from here. Let's start from here. So this is my view of the history of behavioral economics. It might be not exactly accurate, but I'm holding these views very strongly. We wrote these beautiful models like expected utility that it's easy for anyone to take a step because it's so elegant and simple and beautiful. And then we started seeing deviations from expected utility. And deviations from expected utility can come for 2 reasons. One is what I call substantive rationality. This is because the underlying preferences are actually not expected utility. But there is another explanation. The other explanation is procedural rationality. Expected utility really requires you to every little change in prices to start changing your allocation. This is very hard. So while Kahneman and Tversky basically and others promoted that we got the preferences wrong, it's not expected utility, it's prospect theory, Herb Simon actually told us that no, people are expected utility maximizers subject to the choice of heuristics and rule of thumbs that will simplify their behavior. And now I want to give you an example of what do I mean by this. Suppose that I can't, but suppose I could present to you a problem that instead of 2 dimensions or 3 dimensions has 20 dimensions. Now, if you have expected utility preferences and intermediate risk preferences, it means that you always need to choose in the interior of this, of 20-dimensional space. This is mission impossible. So what will you do? And what I'm saying now is very much in the spirit of a beautiful paper that Ariel Rubinstein wrote in, I think it's JET 1987, is there a utility explanation to the Allais paradox? And the explanation is as follows. I'm facing this problem of choosing from an L-dimensional space. What am I going to do? I'm going to approach it in the following way. There are going to be some goods that I'm going to say, either they are too expensive or the probability is too low, and I'm just going to put 0 in them. This is what I call elimination. I will just cut them out. Because in any case, if I maximize my preferences, I will demand so little. So there is no worry. I shouldn't worry about it. The other thing that I can do, if there are two goods that are basically more or less alike, but are not exactly alike, I will say, look, they are close to each other. I will basically bundle them together and will demand exactly the same thing. Okay? So what I will do, I will solve this problem using what I call equalization and elimination. And the bottom line, that if you do it, let's say just with 2 dimensions, it might be that the revealed preferences are going to look like you are disappointment averse. However, your true underlying preferences is that you are not disappointment averse at all. You are actually have very nice, smooth preferences, but you are using shortcuts or heuristics. So the problem is that I really don't have time to go to it, but in the standard problem in economics, what we say that the decision maker is maximizing some utility function subject to the budget constraint. And this part that he has some, psychologists will call it consideration sets, but we will endogenize where these consideration sets are coming from. What's the problem? All the noise we are putting on the utility function, but some of the noise might be on the procedures, might come from basically the constraint. So your constraint is not only the budget constraint. I'm facing some budget constraint in financial markets. I never take into account all prices. I always do elimination and equalization. Okay? And then there are 2 results that I basically ignored. If I do this process of elimination and equalization in a certain way that I cannot now, of course, explain, then the resulting data set is going to be consistent with GARP. So basically, using procedures, if you use procedures in this way, in the right way, you will not have violations of GARP. So revealed preference condition cannot detect that you are actually procedurally rational. Even worse, there is always, the following, it's always equivalent. If there is X star, which is in the argmax of a utility function subject to a budgetary constraint and procedural rationality, there is always X star that is subject to a different utility function that you maximize only subject to the budget constraint. And very likely, this is going to have the expected utility form, and this doesn't. Okay? So all of the deviation that we talk from expected utility, in particular, we can talk about this person. This person, I don't know if this behavior really means that he's not expected utility, or he's an expected utility maximizer that simplifies the decision in a very simple way. He really doesn't want to solve, he doesn't want to get into solving the risk-return trade-offs. Okay? And everything that I did in these 3 hours, I just didn't take it into account. And I basically didn't take it into account because I think that there is kind of an impossibility theorem. Whenever I come and give you an explanation of substantive rationality, I can always also come and give you an explanation of procedural rationality. Yes, A is a set of simplifications. Okay? So all of these biases that we are talking about, this basically says, whenever you tell me here is a bias, I will come and give you, no, there is no bias at all. It's just this simplification. And of course, vice versa. Okay? Thank you.